Welcome to Ask and Learn.
Okay, so for this question, let's determine the least amount of force on the brake that can hold the wheel stationary. So this is the free body diagram for the wheel. So now let's take a look at the moments about point O. Moments about point O can be equal to Fb times 0.15 meter minus 5 Newton times meter is equal to 0. Since we consider the counterclockwise moments is positive, clockwise moments negative. And this will give us Fb times 0.15 meter is equal to 5 Newton times meter. So eventually have the Fb, which is the friction at point B, is equal to 33.33 Newton. So now let's take a look at the free body diagram for the lever. So now let's take a look at the moments about point A. About point A, so we still consider the counterclockwise moment is positive and the clockwise moment is negative. Therefore, have such equation here. So eventually we have P0 is equal to NB times 0.2 meter plus FB times 0.05 meter over 0.6 meter. And we know Fb is 33.33 Newton. And we know the normal force at point B can be equal to the friction at point B divided by the coefficient of the static friction, which is equal to 111.1 Newton. So now we can plug in these values back into the equation to determine the least amount of force that the brake can apply on the wheel to keep it stationary, which is equal to 39.8 Newton. So now let's take a look at the first case. So when P is equal to 30 Newton, as you can tell, 30 newtons is smaller than 39.8 Newton. Therefore, it will not hold wheel stationary. So for part B, when P is equal to 70 Newton, we know 70 Newton is greater than 39.8 Newton. Therefore, when the force P is equal to 70 Newton, the brake can hold the wheel stationary. And these are the answers for this question.